All right, so we're going to talk about our first section for this unit, prime factorization. This skill of prime factorization, I'll explain what it is. Basically, finding prime factors is really important for a lot of things we're going to do throughout this unit. So we're going to talk about today what's a factor pair, prime and composite numbers, like what the difference is, and actually how to do prime factorization, two methods. So really basic, what's a factor? So for example, if you took the number 8, a factor is a number that your original number, like 8, can be divided by. So we're going to be dealing with whole numbers, so like positive integers, so numbers that don't have decimals, stuff like that. So for example, if we have 8, if I said 8 divided by 2, that gives you 4, which means 2 is a factor. You could also do 8 divided by 4, it'll give you 2. So 4 is also a factor. You could also divide it by 8, and you could also divide it by 1. All 4 of those numbers are factors. If you tried to divide it by like 3, you would get a decimal. So 3 is not a factor of 8. A factor pair is pretty straightforward. So again, if we take 8, the idea is it's two numbers that multiply to make your original number. So if we did 8 divided by 2 and it gave us 4, these two numbers, 2 and 4, multiply to give us 8. So 2 times 4 equals 8. That's a factor pair. The other one we have is 8 times 1 equals 8. That's another factor pair. Pretty straightforward so far. Prime and composite numbers. Let's use 8 again as an example. If we want to take a number like 8, and we said its factors are 1, 2, 4, and 8, those are all the factors that fit. This is a composite number. If we took a number like, let's say, 5, the only factors it has are 1 and 5. Everything else gives a decimal. This is a prime number. The reason it's prime is because it only divides by itself, which is 5, and 1. 8 also divided by 8 and 1, itself and 1, but it also had these extra factors. So if any number has extra factors like that, more than just those two, it's composite. The reason this is important is because when we do prime factorization, we want to only find prime factors. So like a basic list of prime factors, right? 1, 2, 3, not 4, 5, not 6, 7, not 8, not 9, not 10, 11, and the list goes on, okay? You don't have to like memorize these. It's helpful to know these ones basically off the top of your head. The ones we're going to be dealing with the most often are 2 and 3. Sometimes 5 and 7 come up. The other one's not really as much. So the whole point of prime factorization is if you have a number like, let's say, 8, I want to be able to break that down into as many factors as possible, all of which will be prime. So there's two methods we can do, the tree and the table. So let's get a little space. I'm going to do the table first because I kind of like it. It's more straightforward. Start with your number. You make a big grid like this. Then what you're going to do is in this box, you're going to divide by a prime number. Usually it's 2 or 3. Okay, so I divide by 2, and whatever's left, I put here, 4. Then you divide it, whatever's left, again. So I divide by 2, it gave me 2. Then you can divide it again, 2, it gives you 1. Okay, once you've done that, you've got all your prime factors. Now, you could do this with a bigger number if you wanted, so something like, let's say, 80. Same idea. I'm going to divide by prime factor, so let's do 2. This will leave me with 40. Divide by 2 again, 20. 2 again, 10. 2 again, 5. And then you could divide by 5 and you get 1. And there you go. That's all your prime factors. I'm including the 1, but you don't really have to. The important ones are these ones on the side. Okay? This method of the the table is pretty straightforward, but as you can see over here, sometimes it can take a pretty long time to list them all out, but as you're also going to see when we do really large numbers, it takes a while because they have a lot of prime factors. You'll also notice that all the numbers I divided by, like I said, are prime because we only want prime factors. That's the whole point of prime factorization. Now, the tree is the method that most people try to do prime factorization like in their head. It works very similar. So it's where you say, okay, I'm going to start with my number 8. Then what you do is you break it into any factors you can think of. So I'm like, well, okay, I know 8 divides by 4. So when I do 8 divided by 4, it turns into 4 and 2. Then you take whichever ones aren't prime and you divide them again. So you say, oh, well, 4 divides into 2 times 2. And there you have your prime factors. Okay? It works the same way as over here, it just looks a little different. Now let's do 80 again so we can see the difference. So I'm going to put 80 up at the top, and I'm like, oh, the first thing that comes in my head, I know that 80 divides by, let's say, 20. Okay? And it also goes 20 times 4. Then I can break down the 4 into 2 times 2. And I can break down the 20 into 10 times 2. And then I can break the 10 into 5 times 2. And now you can see all the factors. Okay? Both methods are equally acceptable. You need to know at least one of them for how you want to be able to solve these questions, because they're basically going to throw a number at you and say, what are the prime factors? We are going to work on stuff later where you're going to need to have access to the prime factors. So this is kind of like a prerequisite skill. That's the basics, and that's it.